All right, let's go a little bit more into TCP. Give you a high-level overview again. Now, again, like we just mentioned, you learn that TCP and UDP are the two transport layer protocols. This topic gives you more on TCP, and next section will give you UDP. Now, to understand the differences between the two, it's basically you need to understand what the basic features are and functions. Now, TCP has the following services that it provides. It establishes a session. So TCP is a connection-oriented protocol. So it negotiates, establishes a permanent connection or session between source and destination devices before any data is being sent. And through this session establishment, the devices negotiate how much traffic can be forwarded at a given time, the communication data, I mean, how often am I going to accept a package or a segment, how often do I need to get validation that a segment arrived. The second thing it does is ensures reliable delivery. So it's possible for a segment to become corrupted or lost, and it's up to TCP to ensure that each segment is sent by the source and arrives intact at the destination. TCP also provides same order delivery. So because of networks that are sent to a source, they don't always arrive in the same order because each packet, each segment takes a different path. So by numbering and sequencing the segment, TCP ensures that segments can be reassembled when everything gets pulled back and received. And then it supports flow control. So part of this negotiation when it's establishing the session, it's because not every host that you're going to talk to has the same power, same memory. So it's got to know how much can I send without overtaxing the receiver. So part of that is done with regulating the amount of traffic. So this flow control allows me to try to prevent needing of retransmission of data because, things get timed out because the receiving host is just overwhelmed. So those are the basically four features that TCP does. Now, to do that, TCP's got a little bit more complicated header than you're going to see in UDP. So you got to have port numbers, because I said ports are what now uniquely identifies your application on your PC. So you've got a source and destination port, and then you've got sequence numbers and acknowledgement numbers, because I'm sending things in sequence, so I'm segmenting it. I got to put a number on everything. So I got to put that number in, store it in the packet, and then I got to say, hey, did I get acknowledgement for that package being received? So you've got these two numbers going through, and then you've got some control information. You've got how big of the header is. I want to know how big. I'm going to how many frames or segments can I send to know if I'm staying intact with everything here. So here's your fields in a little bit more specific data, but basically the one that's always the funnest is this window size, indicate the number of bytes that can be accepted at one time. So you, as the negotiation setting up that session, has to have that received. Now, what kind of applications use TCP? Basically, there are four common ones that use it. And HTTP, Secure Shell, SMNT, FTP, all of those are ones that use TCP. So one thing you want to make sure you understand as we go through this is make sure you know which applications use TCP, which ones use UDP. And when you start getting down to, I don't know if we'll get to the port numbers of each of these applications, but you're going to probably want to know what ports belong to each one of these applications so you know what's being used. So hopefully that gives you a rough idea. Maybe I can go UDP too. I want to go UDP also. let me get past all this. Let's look at the overview here. So what is UDP? Now, UDP, it's basically what we said before. It's a best effort transport protocol. It's a lightweight. It doesn't have a lot of overhead. Now, it offers some of the same data segmenting and reassembling, but without the reliability and without the flow control. So you're not checking if the data, the segment arrived intact. You didn't, you don't care how fast. If you sent too much data for the receiver to handle, UDP just doesn't care. So it's a simpler protocol. So what are some of the features? The data is reconstructed in the order it was received. Any segments that are lost, they're not resent. There's no session establishment. There's no negotiation. And the sending is not informed about resource availability. So I don't even care if you're up and running or if you go down. I'm just going to keep right on sending. So it just has a whole lot simpler information. Of course, you see that when you look at the header information. What do you got? Source and destination point, how big, and a little bit of a checksum. So it really makes it a simple thing. So when you're delivering voice or video over the internet, because you can compensate mentally with maybe some data is being out of sequence. We've all read notes that all the letters are scrambled up, but you can read it and still make sense of it. Well, UDP pretty much takes that what you can do mentally into account, saying, okay, I don't have to be precise like TCP had to be, because us mentally can handle putting some of those things back together. So you've definitely got a simpler header. What kind of applications use this? Well, here you got a whole bunch of others. There's three major types. Live video, multimedia events, simple request and reply application, DHCP, DNS, and then applications that handle some of the reliability themselves. One-directional communications that, where flow control and error checking and acknowledgments are done by the applications, like in trivial file transport, the TFTP. The application does it. Most of your mail applications do it. So I'll let somebody else worry about the application and security and delivery methods. So those become things. Now, even though DNS and some mail programs by default use UDP, both can use TCP. Your DNS will use TCP if the DNS requests or the DNS response is more than 512 bytes. Such as when DNS response includes many name resolutions. And similarly, the network administrator may want to configure your mail system up to be TCP. And that would just be strictly up to the application they want. So just know the basic difference between TCP and UDP, and then we'll go from there. So what I'll do is I'll switch this video off, and we'll go on to port numbers and then probably TCP communication process.